Hi, everyone. Thank you for joining today's webinar. We'll be starting here in just a minute while we wait for people to join. Thank you. Hello, everyone. Welcome to today's webinar. My name is Monica Arevalo, and I'm with the National Renewable Energy Laboratory, and I'd like to welcome you to today's webinar hosted by NREL's REopt development team. Before we begin, I'll quickly go over some of the webinar features. For audio, you have two options. You may either listen through your computer or telephone. If you choose to listen through your computer, please select the mic and speakers option in the audio pane. By doing so, we will eliminate the possibility of feedback and echo. If you select the telephone option, a box on the right-hand side will display the telephone number and audio pin you should use to dial in. Panelists, we ask that you please mute your audio device while you are not presenting. If you have technical difficulties with the webinar, you may contact the GoToWebinar help desk for assistance. If you would like to ask a question, please use the questions pane to type in your question. If you are having difficulty viewing the materials through the webinar portal, we will post PDF copies of the presentation on the REopt Lite website. Today's webinar is being recorded, and the recording will be available on the NREL YouTube channel within a few weeks. Before our speakers begin, I will provide a short overview of REopt Lite. Following the presentations, we will have a question and answer session and closing remarks. The REopt Lite web tool helps building owners evaluate the economic viability of grid-connected photovoltaics, wind, and battery storage at a site. It identifies system sizes and battery dispatch strategies to minimize energy costs, and it estimates how long a system can sustain a site's critical load during a grid outage. The new REopt Lite Open Source software release provides all of the Webtools capabilities and makes the source code available to the public. This webinar will provide an overview of REopt Lite's GridHub repositories and the source code and tools required to build REopt Lite. And now for today's presentation. Our webinar today is Introduction to REopt Lite Open Source. Our panelists today are Sakshi Mishra and Nick Laws, researchers at the National Renewable Energy Laboratory. Sakshi Mishra is an energy researcher and power systems engineer. At NREL, she works as the development lead for the REopt Lite API and its open source effort. The REopt techno-economic decision support platform is used by NREL researchers to optimize energy systems for buildings, campuses, communities, microgrids, and more. Sakshi is also part of NREL's Intelligent Campus project, where her focus is on developing predictive analytics applications. Nick Laws is an energy researcher and systems modeling engineer. On the REopt team, Nick is continuously adapting the REopt model to accommodate the latest technologies, market factors, and user goals. Nick's research interests include identifying and overcoming the technical and market hurdles to integrating distributed renewable energy resources, as well as the electrification of the energy economy. I'd like to welcome Sakshi to start today's presentation.
Thank you, Monica. Hello, everyone. So in today's presentation, we will be talking about REopt Lite tool and its open source version. To start with, the agenda is going to be this way. First, a brief introduction of what REopt Lite is. Second is if you wanted to set up and have the installation working on your computer to leverage the OS or open source version, how to go about that. Third one, we'll be talking about the structure of the full code stack comprising the tool. Fourth one, from fourth section on, Nick will be talking about modeling concepts, the formulation, which is a mixed integer linear programming. And then if you wanted to build further upon this open source code stack, then how to expand it. And if you wanted to take those features which you are building and bring them back to REopt Lite community, then we'll be touching upon the contributions guidelines as well. And we'll have the last 10 to 15 minutes for Q&A. So to start with, just making sure there is a little bit of delay in slides.
You may need to click on the presentation first and then push forward. There you go.
Okay. Yes. So REopt Lite is a free tool to optimize economic and resilience benefits of TER. So what does that mean? In today's scenario, if we wanted to have an on-site renewable generation, behind-the-meter renewable generation technologies installed, then understanding the economics as well as technical factors behind it and coming up with a cost-benefit analysis is not a straightforward decision. It involves first assessing the technology options, which may involve renewable generation, conventional generation, on-site generation, which is existing, battery storage, CHP kind of technologies, and then understand the drivers, which could be cost minimization, or if you want your site to be resilient for a given number of outage hours. And then the economics factors, such as the capital cost of the technologies, incentives from the government, and different financial parameters, as well as the utility cost. How much does it cost to buy the energy from utility versus having to generate from a technology which is getting installed on site? So given those drivers and technology options, REopt can help understand the design and dispatch of on-site generation. What it means is REopt can tell whether to install a technology or not. If yes, then how big the technology size should be and how should it be optimally dispatched to minimize the operational cost. So in this way, REopt Lite tool essentially transforms complex decisions into actionable results, where it tells you that if the given design investment is economic, are the technologies enough to make the site resilient to sustain the outages? And this tool, it's important to note that this tool is based on decades of NREL decision support expertise, where REopt model in itself has been in development for over a decade, and REopt Lite is a subset of the comprehensive REopt model. And I'll be touching upon that in upcoming slides a little more. So in terms of what has REopt been able to accomplish, so far. So it's being used by a variety of users, including developers, utilities, researchers, industry building owners, and all of them are using it to answer different types of questions or different nuances of the same question of trying to understand how does installing a set of technology behind the meter impact the customer itself, or how does it help utility, or what value do these systems provide to the distribution system operations, or maybe for the site owners, how do we optimize the system control or dispatch these technologies to derive the maximum value out of the renewable energy technologies installed on site. And currently, REopt is having more than 1,100 Webtool users and 325,000 API hits so far. So it's being used widely, and users have found it to be very useful so far. So REopt Lite's accessibility. REopt Lite is accessible in multiple formats. One is Webtool, second is API, and third is open source. So the Webtool is a simple, user-friendly, web-based interface for single-site analysis, where users can look at a tool on their internet browsers, give the input, fill in a form of input, and then get output in a nicely visualized way in the form on that Webtool. Second is application programming interface, which is essentially a programmatic access to run the multi-site analysis or embed in custom applications. And the third and the newest addition to the REopt Lite suite is the open source, where the access to the source code for the API part of REopt has been made publicly available so that new features can be added by the users and capabilities can be further utilized. To make it a little more clear, the difference between all three outlets of REopt Lite, I'm using this demonstration. So the Webtool part of it is what is seen on the browsers, and users interact just with that form which shows up and then get the results back on the Webtool. And then second, wrapper. So Webtool essentially is a wrapper around the API code base, and API is where actual pre-processing, optimization, and post-processing of the data happens. And users can directly interact with API using various ways. It can be Python script or a program called Postman. So the Webtool can be bypassed to just interact with API directly. And then what is getting open source is this green box of API. That code base has been made open source. And one important differentiation between the two is the API, which is running behind the Webtool, has Moselle as its programming language for the optimization. Whereas in the version which has been made open source, a language called Julia and its optimization package called Jump has been used to replace the Moselle part of the optimization kernel. So that's essentially the difference between the API and open source code base. So a little bit more on Webtools. So it is offering a no-cost subset of NREL's more comprehensive model, as I was explaining earlier, and it has two modes of operations. First is financial mode, which optimizes PV, wind, and battery system sizes, and also the dispatch strategy to minimize the life cycle cost. And the second mode is resilience mode, where along with optimizing the PV, wind, and storage sizes, it also considers existing backup generators and with the constraint of being able to meet the critical load during the grid outages. So these are the two modes of operation which Webtool offers. API, which is the second part of the REopt Lite suite, is application programming interface, which offers a programmatic way of accessing REopt Lite. And why would one prefer or want to use API when Webtool is already there? API has its benefits, including multiple simulations for different sites can be run programmatically, in the sense that one does not need to keep entering inputs for single site analysis every single time, but a program can be written which can call API multiple times, and the analysis still runs on NREL servers. It also facilitates integration with other programs when done in this programmatic way. Then the newest edition, REopt Lite Open Source, which is the topic of today's discussion. It has been made open source with a few goals in mind, including transparency. We want our users and researchers out there to look at the code, explore it, find equations, and see how exactly the model works behind, under the hood of a web tool. Then flexibility, in the sense that though REopt has lots of features to offer, but users, if they still want to customize it further and build their own capabilities, they can do so with a source code made open. And then collaborations. NREL in our group, REopt Lite group, is very much open to collaborating with academia as well as industry to maybe fix bugs or even build new features going forward. So the source code and tools required to build REopt Lite are available on the repository, which is the address will be available on the slide deck. And NREL will continue to maintain and update the code and to release NREL versions of Webtool as well as API. And open source will still also be maintained and developed further. Just a quick note on the license that it's a BSD3 license, which is pretty permissive. Just to enhance collaboration further, we have made it that way. So installation, working with open source model. If you want to get hands-on with development, then you will need to be installing the development environment on your computer. And for that, we have a pretty comprehensive documentation available on the website. And there is also a wiki. So if you see at the end of the first link, REopt Lite API/wiki pages there have the installation guide, and the one highlighted in the red box is where you will see the detailed installation. So one thing to highlight here is there are two ways. One is Docker, and second is piece by piece installation. So Docker installation is a pretty cool way of doing it with minimum number of commands from user side, and Docker does it all for you essentially. And the piece by piece installation part is downloading and installing different pieces manually with the help of the guides which are provided on the wiki. And another thing to note is we have different sets of instructions for Mac as well as Ubuntu and Windows users. So depending on what your preference is, you can either go via Docker route or piece by piece installation. And for those users who are new to GitHub, they can check out this given link to get a little more acquainted with GitHub as they start REopt Lite development. So let's dive a little bit deep into what the code base actually is. So structure of code base looks like this. So we saw in the previous slide, so there is a web tool layer which surrounds the API layer, and I'm reiterating it one more time that the green box, the API code alone has been made open source. So that API code now has this structure where the innermost part is the kernel or optimization engine, where mathematical formulation and solution of the optimization problem happens, above which there is a Python wrapper where data pre-processing, fetching data about solar, wind, utility costs, and pre-processing it to make it into matrices and arrays which get fed to the mathematical formulation gets done in that Python wrapper. And above which there are four more different packages, and they are essentially there to facilitate more number of site analysis and database, getting the data, storing it in database, results, storing them in the database, as well as Django package is there to help with creating the REST API Celery task management essentially manages the task such that even if you're sending multiple jobs at the same time, rather than burdening the server, it does the computational load management. Then Redis package helps with queuing the tasks, and Postgres database is for saving the input as well as output. So at this point, Nick will be taking over to walk you through 4 remaining sections. Nick, please.
Great, thanks, Sakshi. Hi, everyone. This is Nick Claus. I'm going to talk about sort of a high-level REopt Lite modeling concept, which we just call TECs, which is short for technologies. And those are just generic technologies that can meet loads. And this just concept permeates throughout the architecture that Sakshi described, from the inputs through the Python code into the Julia optimization kernel, and finally back again into the outputs. So this is just some highlights from the API's input. So you can see we have a site object which contains this load profile, financial, PV, wind storage, electric tariff, and generator input objects. And so within each one of these, I'm not showing it, you have all the financial and technology input parameters. What I want to point out here is the 3 really obvious technologies of PV, wind, and generator, and then there's a 4th tech within the REopt Lite model for the utility, and that's made from a combination of the load profile and electric tariff input structure. So obviously, the electric tariff includes all the costs of buying electricity from the utility, but then the load profile input contains things like the outage, start, and end time steps, which determines when the utility is available or not to meet a load. So we have these 4 high-level techs: PV, wind, generator, and utility. So all of this ties into the REopt Lite API tech architecture that Sakshi showed in this way. So you see the Python wrapper, it does these 3 primary steps of setting up the inputs to the Julia model, running the Julia model, and then post-processing it. And we'll see in this next slide, the green checked box overlies this process with the Celery task management. So for most users and developers, the Celery piece isn't all that important. It's more of a production environment piece, which, as Sakshi mentioned, manages the computational resources. So the key thing here is this data flow throughout the REopt Lite API. So I'm showing script names from the Reo directory shown in the upper left-hand corner here. And we're seeing the post come in on the left-hand side into the API.py. This first step just validates that post, fills in all the default values, and kicks off these 4 Celery tasks on the right-hand side. So this first task, scenario.py, takes in that post, which it contains those tech objects, and instantiates equivalent Python objects to mirror those inputs, but they also have behavior as well that ends up getting used in setting up the optimization model. So it instantiates these tech objects, which we'll see in the next slides, as well as the data manager, which relies on those tech objects to create all of our optimization inputs. In the second step, we're running the actual jump model. So we're using Python code to call the Julia optimization, and we're running 2 of those in parallel. So we have a business as usual case, which is calculating all of your current costs of energy over the analysis period. And then another one that's sizing and dispatching the technologies to minimize the life cycle cost of energy. We'll talk about that more in the next slides. Finally, we just have a results processing script that's taking all of those outputs from the Julia model and saving them to the database in a structure that mirrors the input structure, which I showed before. The next piece I want to show is this data manager class. So this is a Python class that, again, uses those tech objects to create all of our inputs to the optimization model. So we're looking now at the REO source data manager Python file, and I'm just showing a couple of highlights from this class. So we see it has some attributes, which are lists of strings for the available tech classes, and the 4 available loads. As I mentioned, a tech is this generic generator that can meet load. And so within the REopt Lite API, we have these 4 loads and these 4 techs. So I'll talk more about this PVNM and WinNM, but NM stands for net metering. And we'll see how this is used to set up the constraints within the optimization model. So you can think of the retail load as the site load. That's what the user uploads to the API. And then the wholesale and export are for, as you'd expect, excess generation could be exported, or even at any time step, say if you do have net metering, the wholesale price could match the retail price. And so that would be equivalent of net metering. Export could have no price compensation, so it'd be like a dump load. And then finally, you see that storage is also a load. So that's why storage isn't considered a tech, because it doesn't just serve loads, but it's also a load itself. So this data manager is then taking in the Python classes, which are contained in the REO source directory as well in text.py. So I'm showing here at the top, we have a base class, which is this capital tech object. And again, I'm just showing one attribute here, so you can see that it has all 4 loads served available. And then we define those 4 major techs: Win, PV, generator, and util. And each one of these technologies can override the base class behavior. So the example I'm showing here is that the utility can only serve the retail and storage loads. And that makes sense. The utility shouldn't be able to export energy to itself, right? So just this list of strings as an attribute of the util tech translates directly into the constraints within the optimization model. So speaking of the optimization model, as Saksi mentioned, it's a mixed integer linear program. And what that means is we have some integer decisions within the model, as well as, since it's a linear program, we could take advantage of very efficient and validated methods to solve the program in a reasonable amount of time. So we're just looking back again at the architecture here. We're focusing now just on the REopt.jl piece. So the objective is to minimize the lifecycle cost of energy, and it's not modeling the entire, say, 25 years. It actually has 1 year of cost and resource data, and then it uses present worth factors to account for the entire lifetime cost in present value terms. So that 1 year of load profile that a user upload is assumed to repeat, but then we're using degradation and escalation factors to account for lifetime performance. One example is, say, the solar PV output is going to degrade slowly over time, so that's accounted for. You might assume too that utility costs are going to increase or decrease over time, so you have a negative escalation factor as well. It's doing an energy balance at every time step for that entire year, so it's not considering power flow or transient effects. It's just one of the key constraints within the model is that that load, the retail load, must be met from some combination of utility energy purchases, behind the meter generation, or discharge from the storage if a storage system is cost optimal to purchase. So each one of these technology modules are based off of real data that's been measured in the field, and so we're trying to model reality as close as possible, right? And then as I mentioned, it's going to size and dispatch each one of those techs as well as the storage asset subject to these resource, operating, and market constraints. And we'll see an example of the net metering market constraints that get applied within the optimization model. So here first is that key constraint that I mentioned for the load must be met at every time step from some combination of generator output and storage output. So what we're seeing here is that the sum of all the techs rated production, so that's DV rated prod there, and throughout the Julia model, so this is in REO source REopt.jl, you'll see decision variables prepended with that DV. And then each value with this P dot is an input parameter. So that's rated production times the resource available. That's that prod factor. So for example, the a solar resource has a time-sensitive availability. When there's grid outages, the utility also has a time-sensitive availability. So that's accounted for within that input parameter for prod factor or production factor. Then the third term there is the life cycle factor. So levelization is counting, say, for PV system degradation. For utility, that number would be a 1. Then we have finally the plus the DV elect from store in a given time step, and all of that must be greater than the load profile for that retail load in every single time step. I next wanted to show an example of a binary constraint that relates to the net metering, or one of those market constraints that we're modeling within REopt Lite. So here we're declaring a binary decision variable prepended with bin, so bin single basic tech. And this is an array of tech and tech classes. And so at this point, these are just those lists of strings that we saw before. And then there's two constraints using this binary decision variable. The first one saying that the sum across all of the tech class must be less than or equal to 1. And the second one is constraining. You can see the DV system size. That's directly related to the DV rated production of each technology. And we have this tech to tech class matrix, which I'll detail in the next slide. And all of that must be less than or equal to the max size for each tech. So that's an input parameter times this binary decision. So the effect of these constraints is to say that you can only choose one tech from each one of these tech classes. And I realize it's a little fuzzy at this point, so let me try to clear all this up. And first, I just wanted to point out that how much the idea of this tech and tech class concepts permeate the optimization model. So as I mentioned, techs are these generic technologies that can meet loads. They all have cost, incentives available, tax benefits available, and we have these 4 techs as I mentioned. This tech class is an abstract group of techs used for the constraints. So this is how the model relates to this PV and PVNM available text that we saw as an attribute of the data manager. So there's one PV that's eligible for net metering benefits, but then to get those benefits, it's subject to this constraint that it cannot generate more than the annual site energy consumption. And so what that's saying is, and this is what most utilities have in their rules, is that if you generate more energy than you consume, you're no longer a consumer, and so you'd be subject to different regulation and different costs. The second PV that's the model can choose from is one that cannot take advantage of those net metering benefits, but by not taking advantage of those benefits, it then can generate more than the annual site energy consumption. And so I put unlimited in quotes here because it's not really an unlimited number in the model. We actually use some big number for that constraint. So this is how we map the tech classes to those tech choices. So this is that P dot tech to tech class matrix. You can see here that's saying that with a 1-0 mapping, the PV and PVNM techs belong to that uppercase PV tech class. And we have the same thing for wind as well in the model. So in these last slides, I wanted to go over some of the contribution guidelines, as well as how you could go about adding your own tech to REopt Lite API. As Sakshi mentioned, we already have combined heat and power tech in the works for the open source code. So if you go to our wiki page, I'm showing the landing page on the right here. If you click on the third link, developing the API, you'll see these 6 steps that are shown on the left. And this goes through the process of creating a new technology within the API with lots of screenshots and lots of details, which we don't have time to go over today. But as I showed through the Python code, you actually don't have to make any significant changes to the optimization model to create a new technology. It's all been abstracted to a higher level layer that makes it really simple to create new technologies within the REopt Lite code. We also have a contributing file in the landing page. So this URL here is actually incorrect. You can remove blob develop from that. But this quick little screenshot here shows how you gives hints on reporting bugs, suggesting enhancements, as well as creating pull requests with links with more details. And so that first one there, if you clicked on that issue one, you go to the issue tab on our GitHub repo, and then we have a template there to help people fill in if they want to submit a bug report or a feature request to the REopt Lite developers. And we've also you have the ability to create your own bug fix or your own feature for the REopt Lite API. So this is on the right, I'm showing an example of that process. So the central repo here would be the REopt Lite API repo, and you'd have to create your own fork, clone it, do your edits, push up, and then create your own pull request. And so you would be essentially making a request to our NREL scientists and engineers to say, hey, I've got this really cool thing I'd like to add, or I fixed something wrong with it. Would you please merge this into the central repo? It's important to note that we've actually used a test-based development throughout the process of the REopt Lite API. So when a user creates a pull request, it will automatically kick off a test suite via GitHub Actions. And so each one of these built-in tests, there's a few dozen of them, test an individual feature that's been added over time to the REopt Lite API. So we ask outside collaborators and developers to do the same thing. So when you create something new, you would design a test that shows that that feature is working as behaved. And that's really helpful for the long-term development of the API, because if somebody else comes along and creates a new feature or fixes the bug, and then you see that that old test is failing, it's a red flag, right, to go check on, well, should the behavior have changed, or did something we did change the behavior in the wrong direction? It's also important to note that not every pull request will be merged. So there's a few requirements that have to be met besides just passing the test, right? So we try to preserve backwards compatibility, especially as more tools get built on top of the API. That's really important to make sure everything works as expected before you created your change in the code. It also, what you submit as a pull request should have wider user community benefit, and every pull request will go under an NREL internal review process. Lastly, I just wanted to mention that we are developing a forum for community support, and so that will not only include outside developers, but also NREL scientists and engineers will be using that forum for support throughout the process. Lastly, we have a lot of links here that we've to the resources mentioned throughout the webinar. I want to highlight the last one, which is reopt.nrel.gov, so you can reach out to us there with feedback and questions besides, if it's something outside of a bug fix or a feature request, like I mentioned. And also, we'd love to hear back on just how you're using the tool, what kind of tools you're building on top of it, on top of the REopt Lite API, and all of these testimonials help us keep funding the development of the REopt Lite API. So with that, I'd like to thank everybody calling in today, and then we're going to start working through your questions.
Thanks, Nick. We have a couple of questions so far. So first one is, can participants expect to have access to presentation material? To that, yes, we'll be posting the material on REopt Lite website in upcoming couple of weeks. Second question is, when will CHP module be available? The development timeline is for it to be available by end of September. Those were the questions we had so far. There's another question. Can you show dispatch optimization? Not very sure what the question is asking. Nick, do you want to try to attempt to
Sure.
understand?
Yeah, so it's not an algorithmic dispatch optimization. That's sometimes it's a common misconception. So there isn't like any sort of rules within the optimization model. The objective function, minimizing the life cycle cost of that energy, is really what's making the dispatch decisions at every time step. And it's not a time marching model, so it doesn't say at time step 10 what is the optimal decision, whether to charge or discharge or export energy. It's actually, because it's a mixed integer linear program, it's omniscient, so it sees every time step as it's minimizing that life cycle cost. So it has what you might call perfect foresight, right, over that entire year. So it can, as it makes the decisions for charging and discharging and exporting, all of those decisions are tied to that objective of minimize that life cycle cost of energy. So to show like how the dispatch is done in the optimization model, I would show just that objective function as well as say the operational constraints in the model. So you'd see things like in each time step, you can only charge the battery as much as the inverter allows, and that inverter capacity is a decision variable as well. So it's optimizing everything, including dispatch, inverter sizes, energy capacity, minimizing that life cycle cost, all at the same time.
Thanks, Nick. The next question is, are there specific features you would like to have community members work on? Would the forum be the best place to ask?
Yeah, I think as soon as we get the forum up, go ahead.
Nick, go ahead, please.
Yeah, the forum would be a good place. It's not up yet, unfortunately. That's a great question. I haven't thought about it. What would be an ideal place? That's a really good question. Do you others on the phone, Josiah or Sakshi, have ideas?
Yeah, this is Kate. I would just say that we do get a long list of requests from our users, and so maybe we can think about posting those either on our website or our forum to give members of the community ideas about what folks are asking for and what might be most useful.
Thanks, Kate. Next question, how will this affect the website version of REopt Lite? So I think website version of, go ahead, Kate.
We intend to keep building and expanding on the website version of REopt Lite. So our intent is not for the open source to affect that at all, but just for the open source to provide one more means of accessing these capabilities.
And I could imagine if there was something very cool came out of the open source development community, right? That could be something that leads into a really new feature in the Webtool as well.
Thanks, Nick. Next question, can you explain licensing? I think Kate will have a first answer for it.
Sure, so the license is a BSD3 license. So when you go to download to the GitHub page for the REopt open source, you'll be asked to agree to the license there. BSD3 is a very permissive license, so it allows you to use the code and does not require you to make any of the changes or contributions that you make publicly available. We do, of course, appreciate if you do make changes that might be useful to our user community if you do contribute those back, but it's not required.
Thanks, Kate. Next question, REopt can be used for long-term planning also. Is that the case?
Yeah, you can essentially think of the first year as any year. So if you wanted to use forecasted prices, within your inputs, then you'd be modeling from say 2030 to just see if it would be optimal to invest in behind the meter energy resources in 2030.
Thanks, Nick. Next question is, do you have any publications which demonstrate how to use REopt to solve application problems?
Yes, I suggest visiting the reopt.nrel.gov website. On there's a link to all of our publications, and there's a lot that are specifically on how we at NREL have used REopt to help specific clients and partners solve actual problems.
Thanks, Kate. And I think to add to that, we are also working on a couple of publications which will be out. We are hoping to have it out in a month or so, talking in detail about REopt structure, open source structure, as well as potential applications. So yeah, that will be posting it on our website once it's out there. Next question, is there a way to change the input load profile to capture energy efficiency measures within the optimization?
So the REopt Lite doesn't contain energy efficiency decisions within it, but our in-house model does. So you could, feasibly choose a different, say, load model. So rather than just a tech, as I talked about, the full model also has some dispatchable load models within it. So that's something that's currently not available in the open source code. But the load profile is just an input parameter, so you could definitely run any load profile you want. There's the option to use the commercial reference building profiles as well, and you can scale those as you want, either to an annual, say, energy consumption value or a monthly energy consumption value that you can take from your utility bills.
Thanks, Nick. Next question. Are the optimization formulation equations are open source too? If yes, where is it?
Yes,
I can take. Go ahead, Nick. Sorry.
So that's those screenshots I showed from reo/source reopt.jl. That's the optimization model. So all of those, all the formulations there in open source.
Thanks, Nick. Is anyone adding biomass and especially biochar for carbon negativity to this program or plans to do so?
There have been considerations to add biomass as a fuel as part of the CHP module that will be added in September, but nothing on biochar at this point.
Thanks, Kate. Next question. Are there plans for more realistic control algorithms for storage without perfect foresight?
Yes, we've been thinking about that for a while, and I think some past work has looked into it. For example, you can take the REopt sized DER and then run them through a time marching simulation, which would dispatch them using rule-based strategies, and then you'd see, of course, presumably a lower benefit from those DER using a scheduled dispatch versus the optimal one from REopt. So we think of REopt's solution as that upper bound to what's achievable. So it has been used a lot as a screening tool to say, okay, under best case situation, what kind of savings we could achieve. But we do have some work looking at that, how to present the results of rule-based dispatches to users to sort of to quantify some more of the uncertainty involved in these investment decisions.
Thanks, Nick. Next question, any plans to fit the tool into a stochastic programming paradigm?
So this ties into what I mentioned, just as well as like quantifying the uncertainty in this decision-making process. And we do have some stochastic programming models in development at NREL related to REopt and REopt Lite, but there isn't a plan in the near term to make that part of the open source code. Some of the things we've been considering are sort of random outages, so thinking about that resilience mode like the Webtool has, but there isn't a plan to make it open source, I think, anytime soon, but it would be certainly, that could be a good avenue for part of the collaboration that could come out of the open source code, is developing some of those stochastic optimization capabilities with REopt Lite.
Thanks, Nick. Next question, is there a roadmap for planned development from NREL for new features? So quick answer, yes, and the detailed information is on our website for the planned development. Next question, does REopt support multiple outages in a year? Currently, it is not supporting multiple outages, but that's something which can be modeled with some effort, I believe. If that's something community wants to pick it up, then yes, we can be of help in that. Next question, what is the size of the current community of REopt Lite? So I had this information of one of the slides. We have around 1,100 plus Webtool users and 325,000 plus with API hits so far. And in regards to REopt Lite open source community, since this has been open source recently, so and we are setting up the forum, so the community is building up, and we are hopeful that it's gonna grow soon. Next question, how does REopt compare to Homer, and is it legal for NREL to compete with private sector? Kate, do you wanna address this?
Sure. Yeah, sure. So REopt is primarily based on a mixed integer linear program, which is a little bit different than how Homer does it. Although I think the end goals of both Homer and REopt are somewhat similar. They're both trying to advise on kind of the most cost-effective energy mixes to meet energy needs at a site. I think there's lots of energy tools out there, certainly, that do this. One of the things that is perhaps a little bit different about REopt Lite is the ways in which we're making it available. So our hope again is that through things like the free Webtool and the API and the open source, there'll be a lot of opportunities for people to kind of take these capabilities and build their own tools on top of this.
Thanks, Kate. Next question. If users have an established Julia environment, can REopt or REopt Lite be used in an on-premise mode without reliance on external servers? So there are two parts to it. External servers, that is NREL servers, they are used only for REopt API, where it's essentially sending the data over JSON. The server runs the analysis and sends back the replies or output in a JSON format, versus the open source version where users are essentially setting up the development environment on their own machines or their servers if they wanted to, and then it's the optimization and the whole pre-processing and post-processing is happening on their servers. So that's kind of the difference between API and open source. And just to reiterate, open source version alone has the Julia programming language with jump optimization package. Next question.
And this is Nick. I just wanted to add to that, Sakshi, that the reason we did that is using Julia with the open source version is so that it would be easier to use lots of different solvers with the mixed integer and linear program, whereas the version that Sakshi mentioned that we're hosting on our own servers here at NREL, which users can hit the API as they wish, that's using a Mosel model, which only works with Express as the solver. So before we open sourced the code, we translated that Mosel model into JMP so that the user community would be able to solve it with any solver that they have access to.
That's a good point. Thanks, Nick.
I'd also like to add real quick, Sakshi, that kind of on the terms of external servers. In a lot of ways, there aren't any external resources you need. Certainly, we kind of bring in resource data from various other APIs, some of which are developed at NREL, but you can certainly run the whole thing from your own laptop. It's not like you have to have multiple machines for this type of thing. And, if you are to take that a step further, the Julia code that we have in place, are just kind of in functions, and you would have to structure your data in a specific way that the API is conducive to. But kind of if you structure your data as kind of the functions that we call from the Julia side of things are structured, you really could bypass a lot of the Python API and just use the Julia code with the JMP model.
Thanks, Josiah. Next question. Are there limitations on the commercial use of the API? Kate, do you want to address this one?
I don't believe there are limitations. There's some language around how we do or don't endorse any results that come out of the API that we have not personally been a part of. But besides that kind of legal language, there aren't limitations.
Thanks, Kate. Next question, can you specify self-consumption? I think the question is, can load profile be uploaded, or if you have the consumption profile of your site? The answer is yes. Next question, is the PV simulation engine using PV-libsam or PV bots? So we use PV bots for PV production factor and SAM for wind production factor. Next question, how does the degradation impact the optimization? Is it a linear multiplier on objective function, or is it actually changing the dispatch each year? So is it the, assuming it's the degradation of PV and wind, so it's a linear multiplier, yes, it's multiplied to the objective function. Nick, do you want to add something to it?
Sorry, could you repeat the question?
How does the degradation impact the optimization? Is it a linear multiplier on the objective function, or is it actually changing the dispatch each year?
Oh, I see. Yes, it's, as you mentioned, it's just a linear multiplier. So it's that formula I showed that had that levelization factor that rolls the entire, say, 25 years into just a scalar to account for the average output, say, over the 25 years. So the prod factor is a parameter, has the the perfect capability in year one, and then levelization factor is essentially a knockdown factor, right, to account for the lifetime degradation.
Thanks, Nick. Next question, are there plans to expand the API to include more features from internal tools? So answer to that question is yes. The tool is being expanded with new features, and the plan for development is on the website. Next question, beyond what is available through JMP, is REopt Lite able to leverage the Julia language multiple dispatch features? So at this point, Julia language in general does multiple dispatch, but currently we have not set it up to do so, but that's something we are considering for the future plan. Josiah, do you have something to add there?
Yeah, definitely. So even just in the Julia code that we have built, it does use some multiple dispatch just to make things a bit cleaner, but certainly, yeah, you could use it. We aren't dispatching kind of our optimizations on different types at the moment. And part of that is, we are running these models based on kind of these Python types that are translated into Julia types. So it does kind of limit our usage of that. But certainly if we kind of move in a direction where we are perhaps only pulling in certain parts of the model for various optimization problems, we could certainly add some sort of type inference into that sort of paradigm. But yeah, it's used but limited, and it certainly could be expanded, but there are some limitations associated with kind of the Python workflow we use.
Thanks, Josiah. There are a few more questions left, but seems like we are running out of time, so I'll request Monica to guide us. How can we? I think
actually I'd suggest that people can contact us through REopt@nrel.gov if we didn't have a chance to get their questions answered today.
Sounds good. Thank you, Kate. So thanks everybody for joining the webinar. We hope that you find REopt Lite a useful tool, and please do check out the open source version, and we'll be in touch with the community over the forum which we are developing. Thank you again.